We're talking about rocks on this episode. Geology. In fact, rock types.
Rock types.
Probably sitting there now thinking, why do I need to learn about rock types? Why did I click this video? Well, I'll tell you, rocks are cool. Even if you're not going to be a geologist, it's really important to know what you're looking at. For instance, we do a lot of rock climbing, we do a lot of adventuring. We went last week to Red River Gorge in Kentucky, world famous for its rock climbing. And you talk to any rock climber there, they're going to know what rocks they're looking at.
It's composed of Corbin sandstone, which is a sedimentary rock.
Now besides that, it makes you sound smart in general because you look at a rock face, especially beautiful arches or deep canyons, and people, very commonly ask, how did this form? Where were these rocks before, right? And so if you know a little bit about rocks, you can take a stab at that answer, and even if you're not right, you sound pretty smart doing it. But first, you gotta know rock types.
The igneous.
Now start with the igneous because it's the natural place to start. It's where new rock is formed from molten magma. You see, a couple years ago, Hale and I went to Hawaii. We marched out along the coast of the big island of Hawaii, and we were able to see new rock forming when none existed before.
Glowing behind us, new earth being made.
It's lava forming igneous rock.
When that lava, or magma in some cases, cools, it becomes an igneous rock.
Right there. If you were wondering how rocks were formed, there you go.
Now, when magma cools slowly, it forms really beautiful crystals. The slower it forms, the bigger the crystals, right? So if you were, say, climb the Grand Tetons, which we did last month, you're able to see these giant crystals on the surface of the rock, and it's just awesome. Moving on, sedimentary rock.
Sedimentary rock.
Sedimentary rock is really cool because every sedimentary rock came very clearly from other rock, and you can almost look at the grains and see it because that rock basically got cemented together from the parts of other rocks. Got cemented together. How cool is that? And maybe the coolest manifestation we've seen is when we went through the Grand Canyon. And not only are you seeing these giant cliffs of exposed sedimentary rock that, are going back millions and millions of years, but you're actually on a river that is actively moving sediment away and depositing it somewhere else.
Metamorphic rock.
A metamorphic rock is just when you take any of the other rocks and you put them under heat and pressure and you twist them and meld them up. Now here's a rock climbing place in Golden, Colorado that we like to climb that's metamorphic rock. One of the coolest places. First, to get to it, you gotta climb up a tree and zip over on this cable, and then you're climbing up the wall. And one of the things you'll notice is that when you're climbing the wall, the whole wall is like twisted and melded up. And that is metamorphic rock because it used to be granite. The reason for me wanting to tell you about rock types is just to get across the point that rocks change. You see, if you were to look at a rock cycle, you would see that any of the rocks, if they get broken down into little pieces, they can reform into sedimentary rock. If you take any of the rock types and you heat them up until they become molten magma, when they cool, they'll become igneous rock. And then likewise, if you were to take any of those forms and put a lot of heat and pressure on them, they will become metamorphic rock. So almost every rock can become another rock in this giant, cool rock cycle. So there you have it. Rocks are pretty cool, especially the more you know about them. If you clicked on this video, chances are you're studying for a test. I hope that helped. If it did, let me know in the comments below. We got a lot of other videos to watch on all different types of science, so check them out. Subscribe to our channel. Get ready for videos every single week.
Okay, so after watching the video, what can we conclude about the rock cycle and layering? That the oldest rocks are on the bottom. Right, and the newer top rocks on the bottom, like you see this illustration, are going to be sedimentary rock. It's basically rock that's gotten washed away from riverbeds, maybe got taken away by the air, transported and then deposited in other areas. Through lithification, it becomes sedimentary rocks. Okay, some of the objectives in this course are going to be the ability to identify rocks and the transition from one form to another, be able to accurately draw a rock cycle, explain the rock cycle process, and you guys will generally be able to understand the bottom layer of built-up sediment will generally be older than the one above it. Okay, some of the California science standards. The California science standards for this classroom require each student know how the rock cycle includes the formation of new sediment and rocks, and the rocks are often found in layers, with the oldest generally being on the bottom. That is what is expected of you students. Okay, the California Science Standards are requirements that the state of California requires that each student know. The standards that we will be expected to learn in this lesson and through this classroom will be that the ability for students to know the rock cycle includes the formation of new sediments and rocks, and that rocks are generally found in layers, with the oldest generally being on the bottom. Okay. Now you guys will assemble your rock models. What I want you guys to do is basically in these clear jugs that are in front of you guys need to go outside, collect 3 different types of materials, fill up your bottle as best as you can with one material at a time.
So the materials, can they be all dirt, or can they be other things?
They can be dirt, leaves, just as long as you guys put them in 3 different layers. What I want you guys to do is kind of resemble the rock cycle here, where you have 3 different layers, where sedimentary rock, metamorphic rock, and then it eventually transition into this magma that will eventually come up into this intrinsic rock. Okay? So let's go ahead and do that right now. What is significant about each layer in your model?
The bottom is the most compacted.
There you go. Good. So that, like the bottom compactness, that's kind of what happens towards the end. You know, at the top it's kind of loose. It's sedimentary rock like you find in nature, like sandstone. That kind of breaks apart easy. And then as it starts to go down, it starts to get compacted and become metamorphic rock. And then eventually it'll reach the magma, which will heat it and eventually shoot it back up in the form of igneous rock, which is usually cooled magma. So in your model, what would be the newest, Ethan, for example, in your model, what would be the newest soil there?
My newest soil would be the green leaves.
Correct, because that's the one on top. And even though it's intermingled, the green leaves tend to be on top. And you'll see that in nature. I mean, as you look right here, it's kind of at an angle. It mixes up, but generally the deeper it goes, the more older it will be.
So is that why when you plant something, it's harder and harder at the very bottom, and you start getting more of those rocks in there versus sand, and then like the compacted sand, and then it turns into almost like a gravel?
Exactly, and I think that's why it's like it just depends on what kind of weathering was happening at that time, where the rocks were coming from. And that's why you will see different layers of soil, whatever may be in the air at that time. And that's kind of how they can track the ice age and stuff like that. Pollutions in the air will be in our soil comparatively to soils past.
So how deep do you have to go to change actual rock formation? Are we like 5,000 years? Do you have to go 10 feet? Do we know how deep we have to go? Do you know how deep that is?
What do you mean? Depending on the elevation, pressure, and other stuff like that. Because in order for it to become metamorphic rock, there has to be enough pressure on it to change it into that different type of rock. So it completely varies on location.
Sea level, stuff like that.
And I have a question. What is the black layer, the gray layer in between sedimentary?
Versus uplifting.
So yeah, so right here is going to be your uplift and exposure. It's basically the soil that's not completely going into the metamorphism. It's going to go back up, and it's going to get, whether it happens from water or something like that, it takes it back out, and it'll shoot it back up, and it'll start all over. Just because it gets to sedimentary rock doesn't mean it's going to go directly into metamorphic rock. Sedimentary rock is loose, and it can be carried away by rivers, stuff like that, wind, and it'll just go back into the air, and it'll come back and do the same process again. Any other questions? The rock cycle's key terms. Metamorphic, as we've seen in the presentation already, is the change because of heat or pressure. Can anybody tell me what meta means?
Change.
Correct. Therefore, it's the change of rock. Igneous rock. Anybody want to read that out loud?
Igneous are rocks formed from cooling magma.
Right, and in the illustration here, it's going to be like coming up the magma into these volcanoes, pours out an igneous rock, it's weathered away, or just comes straight down and heads into the rock cycle. Sedimentary rock. Anybody want to read that one out loud?
Rocks formed when layers of sediment settle on top of each other and from layers that eventually harden together.
Right, and that illustration is going to be the yellow sediment here that transitions to metamorphism and then metamorphic rock. These three rocks interchangeably make up the rock cycle.
What's older, metamorphic or igneous?
So you would follow the rule of which one's lower. Here in this illustration, for example, the igneous is up here.
Like in Hawaii, like the volcanoes.
Correct. So the metamorphic rock is down here. It's going to be older, and then it's going to have to come up and be on top. Therefore, it's going to be the metamorphic rock is going to be older, and the igneous rock is going to be newer. Go ahead.
So, are we finding more fossils now because it's going through the rock cycle, and so it's going through that circle? So it's the metamorphic rocks now coming back up, and it's becoming to where, you know, the sediments and the layers are being taken away from rivers or winds or whatever, and so we're discovering more fossils because it's clearing it away from the actual bone or the fossil.
Correct. The sedimentary rock on top is constantly being moved aside, and the fossils, you gotta realize, aren't getting any older. They're still the same fossils we've been finding. So the sedimentary rock is slowly weathering away, and we're getting access to more fossils. I don't think the fossils are increasing. We're just having better access to them.
So it can take millions of years for a rock cycle to completely go full circle.
Correct. So what are some examples of layered rocks in nature? Where do you guys see these layering of rocks?
Like in the Grand Canyon?
Exactly. In the Grand Canyon, you have different levels of, you see like different colors of reds and browns, and that's going to be layering that happens through time. And you can see it in the Grand Canyon because of the unique, the way the structure was built with the water cutting through the ground and giving you these visuals.
So like slate's the same way. Slate is very layered.
Right, right. So that would be like, and because slate is very brittle, you can pretty much assume that's like a sedimentary rock. Just make that up.
Sounds right.
So, could you guys tell how old a dinosaur is by what rock it's found in?
Yeah.
Depends on what layer it's found in.
Correct.
Or how far deep.
Yeah, and if you can basically date the rock, you can basically date the fossil, because whatever that dinosaur died in whatever time that rock was formed. So, next PowerPoint is earthquake. Let's try to use your models and pretend like there's an earthquake. Not the end of the world here, just a slight shake in your guys' sediment structure. Okay, so what have you guys noticed about the changes to your structure there?
Some of the layers are mixed up.
Yeah, what else?
The top layer is not really the bottom. Only the top layers have shifted. The bottom has stayed the same.
Right. So even though, you know, this happens just in nature, as you guys can see in this illustration, when the earthquakes happen, it may shift the soils and it may move them around, but you can still see that the bottom layer will still be the bottom layer, and the top layer will still be the top layer. It may have been moved around a bit, but if you follow the fault line, you can still see generally which soil is the oldest.
Well, now the bottom looks more compacted, so it's almost like the earthquake filled in with all this extra space at the bottom, and that where there was air with more like granules and more sediment, to where it's becoming more and more compacted down.
Right. Alright guys, so that is it for today. Tomorrow, be prepared to do your own illustrations of the rock cycle, kind of like we have here. You know, I want you guys to be able to draw this with all the correct illustrations. Do you guys have any questions right now before we end?
What is lithification?
So lithification is the process of when the weathered material is flowing through the sky and it settles, and after it's deposited on the ground, it goes through lithification and becomes sedimentary rock. So tomorrow, be prepared to do this. When we get to class,
Does it have to be in color?
no, but volcanoes and dinosaur bones are a bonus.
Why do you say so seriously? It sounds like it's supposed to be a joke.
No, it's not a joke.
Okay.
It's a bonus. Can everyone conclude conclude that we did hit our objectives. Can everybody tell me that they are able to, you know, accurately draw a rock cycle and explain how the rock cycle occurs?
Yes.
Any questions? Okay, thank you for your time. You guys have a good day. Okay, for extra credit, guys, you guys can head out this weekend, maybe do a hiking trip. Try to see if you guys can find some examples of layering occurring in nature, whether it's like climbing a mountain, maybe a mountainside. And even if you guys can't go on a hiking trip to the mountains, maybe you guys can dig a hole in your backyard and take a picture of it. And next classroom we can share it, share our experiences, and see what we did this weekend. Okay?
Okay.
Thank
How
you.
many extra credit points?
100.